What's up, everybody? Welcome to another fantabulous video lesson. Oh my goodness. Anyway, let's get cracking on this. So in class, you will have learned about measures of position for non-group data, the median, the quartiles, the deciles, the percentiles. Today, I'm going to show you, or in this lesson, I'm going to show you about how to find the measures of position for grouped data. All right, so with that said, let's get to it. Group data means frequency table, and here's a frequency table right here. We have certain classes with grades, let's say on a quiz, and corresponding frequencies. What I'm going to do is I'm going to create a histogram right now, okay? And the reason I'm going to create a histogram is because I am going to write a definition before I even get to this right here. The first measure of position that we'll talk about is the median. We'll get to that right now. So let me just write that down. The median. We know that as the middle piece of data. However, what I'm going to write here is that the median in terms of group data is the vertical line that divides the histogram. Not divided, it divides the histogram into two equal areas. So what do we need to create a histogram? We need a column of class marks. Keep that in mind, your class marks. So I'm going to write this in red. There's going to be two columns that I'm going to do in red. And the class marks here are going to be what? 4, and then 4 plus 5 is 9. And why am I adding 5? Because the class size is 9. 7 minus 2 is 5. 9 plus 5 is 14, then 19, and then 24. All right. And so I'm going to create a little extra thing over here, but I'll do that momentarily. All right. So what I'm going to do right now is I'm going to create a histogram. I'm going to zoom out a little bit here, just because I want to have a little bit more room to play with. And so let me create a histogram. If we were in class, this would be the point in time where I would have you make this all by your lonesome. This would be quiz time, but you've already taken the quiz on this. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 4, 9, 14, 19, 24. And then my highest frequency is 15, so I'll do 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. Then I'm going to do my classes. The first class goes up to 3. Next class goes up to 8. Next class goes all the way up to 15. Then back down to 8 again. And last but not least, 6. All right, so what's going on here? We want to find the median. Now, I see that there are 40 pieces of data. So half of 40 is 20. I know that there are 3 pieces of data here. I know that there's 8 pieces of data here. 8 plus 3 is 11. So 11 plus what gets me to 20? 11 plus 9. So if I were to draw a value right there, those are 9 pieces right there. I've got 3 here. I've got 8 here. 8 plus 9 is 17, plus 3 is 20. Perfect. That's 20 there. I just found my median. And then, of course, there's what, 15 pieces of data, so that's 6 other numbers right here, and then 8 and 6. 6 plus 8 plus 6, that also equals 20. Woohoo! I found the median. Oh, wait. Look at the definition. The median is the vertical line that separates the histogram into 2 equal areas. So guess what we got to do, everybody? We have to draw this same histogram all over again. And yes, if we were in class, we'd do the same annoying thing where we'd do this histogram all over again. 3, 4, 5, 4, 9, 14, 19, 24, 3, 6, 9, 12, 15. This goes quickly because I have already drawn it once. We've got 3, 8, 15, 8, and 6. Okay. I think we can all agree that the median is going to fall somewhere within this third class, right? It's going to fall somewhere within this third class. That's what the median will be. However, I'm going to draw a vertical dotted line this time. And why did I draw the vertical line there? Well, just keep in mind, how many numbers are in this third class? There's 15 numbers, right? There's 15 numbers in that third class. I need 9 of them. So bear with me for a second, because this is almost going to get a little, geometric on us right here. But this dotted line, doesn't that represent 9/15? See how I turned it into a fraction? We have 15 numbers in the box, in the rectangle. We need 9 of them. But it's the 9/15. And let me call this here. I'm going to call this point A, and I'm going to call this point B. It's almost like we're getting in our car and driving. We're driving from point A to point B. This dotted line represents 9/15 of the distance from point A to B. Kavish? Makes a bit of sense right there, right? Great. So how do I determine that? What is point A? What is point B? Well, point A, let's start with that, and let's finish with that. That is the separator from the second rectangle to the third rectangle, but there's no gap. Wait a minute. What measures have no gap in between the classes? The class limits or the class boundaries? It's the class boundaries, Mr. Clody. That's great. I heard somebody at home say that. It is the class boundaries. So here's what I'm going to do. This is very, very, informal, but I'm going to just write the lower limits here. What's the average? What are class boundaries again? It's the average of an upper limit and the next lower limit. So the average of 6 and 7 would be 6.5. And the average of, so then I'm just going to add and subtract 5 to each one. 1.5 if I subtract 5. 6 plus 5 is 11.5, and 16.5, and 21.5. So what do those red numbers represent? They represent the beginnings of each of these classes. 1.5, 6.5, 11.5, 16.5, 21.5. That's what they represent. So point A is that right there. So to figure this out, to figure out what the median is, I'll stick with the red. The median is going to be simply that point A right here, which is, what is the beginning of that third class? It is the 11.5 right there. So I'm going to keep it on screen. The 11.5 plus. Then I need to travel 9/15 of the distance from point A to point B. What is the distance from point A to point B? Another vocabulary word. The distance from point A to point B is just the width of the rectangle, AKA the class width. The width of the rectangle is just the class width. What is our class width here? Is it 4 or is it 5? It's 5, Clody. It's 5. So then I just multiply, I start at point A, which is this, and I add 9/15 of that width, of that distance from point A to point B, and what I get is a number. And that number is the median. Congratulations. We've just found the median of a set of grouped data. Woohoo! I know, you guys are all pumped. Great. You're thinking, oh my gosh, am I going to have to do this for every problem? Don't worry, we're going to do some more examples, and this will become easier. And if you, even after you watch this video first, or one time, watch it 2 or 3 times. Even after that, if you're confused, don't worry. We're going to be doing this in person in class the next day, but you need to make sure you know how to do this. You got to do the homework as well. All right, so one other thing I will recommend that you do, and I am going to do this in blue this time. Create one more column. And here we have frequency on the left. I'm going to make one more column, call it cumulative frequency. I'm going to say this, I cannot stress this enough. Completely informal. This is not the correct way that we've learned cumulative frequency. Remember, cumulative frequency begins at 0 and then goes down. I'm just going to informally write what the cumulative frequency after each step is. So there's 3 numbers after the first. Then 8 plus 3 is 11. 11 plus another 15 is 26. 26 plus 8 more is 34. 34 plus 6 is 40. Notice I got all 40 numbers after that. Why will this cumulative frequency column help me out? I will explain as we get to future problems on this in this lesson right here. But the two columns that I think are most important that you need to create yourself is the lower boundary column and the cumulative frequency column. Those two columns are going to help you more with this assignment than anything else, in my opinion. Okay, so to be honest, I can absolutely, oh my gosh, what's going on here? Why is this not allowing me to go through here? There we go. Now let's see. How do I scroll this down? How can I scroll this down without, no, it's not allowing me to do that. Why is there always a technical snafu when I'm doing stuff with paper here? Select. All right, let's do this now. All right. Okay, so now that we're here, let's get to the next thing here. So I am going to write a verbal for this statement. We made verbal statements in our last lesson, and my verbal statement for this one is that 50% of the data is less than or equal to 14.5. I want you to pay very close attention to what word I did not use. I did not use the word approximately. Why did I not use the word approximately here? Because this is grouped data, and we are assuming, I know whether it's correctly or incorrectly, we are assuming that the data is evenly distributed throughout each rectangle. We don't know if it is. We don't know if it isn't. It's grouped data. So we're going to assume that it is. So we are assuming that we found the exact 50% value, that line right there, that vertical line. So with non-group data, you use the word approximately. You're going to learn that in the lesson in class. And then, or we learn that in the lesson in class, depending on when you're watching this video. For grouped data, you do not use the word approximately. I'm going to make that no approximately. Okay. So the verbal is pretty quick, basic right there. All right, let's get to the rest of the quartiles. So let me say this here. The quartiles divide the data into 4 equal areas, and they are the same notation as they were with non-group data, Q1, Q2, Q3. So let's find them right now. Q1. At this moment, I'm going to say it might be useful to pause this video and have this frequency table at your disposal right next to you, because I'm going to be continuing to go up and down, and your eyes might get blurry from this. So if you have this frequency table on a separate piece of paper right there where you can view, it will make your life so much easier. So first and foremost, the first quartile is a quarter of the way through the 40 numbers. There's 40 numbers in the set, and it's a quarter of the way. So that's 10 numbers. So does that mean that 10 is the first quartile? No. It means that the 10th number is the first quartile. But where does the 10th number fall in this frequency table? Well, take a look at the frequencies. After one class, there's 3 numbers. In the second class, there's 8 numbers, but after 2 classes, there's 11 total numbers. I'm looking right here now. Do you see that? After 2 classes, there's 11 total numbers. So the 10th number must fall somewhere within that second class. Do you understand that right now? The 10th number is hiding somewhere within the second class. So I'm going to make that little note to myself right here. The 10th number will fall somewhere within, oops, let me get out of that. Hold on. There we go. And there we go. All right, good. The 10th number is going to fall somewhere within the second class. So in order to find the first quartile, and I'll do this in red right here, I must take the lower boundary of that second class. What's the beginning of that second rectangle? It starts at 6.5. You see that right there? 6.5 is the beginning of the rectangle of that second class. It would be right here, if you think about it. That's the 6.5. So I'm going to start at 6.5. Then I'm going to do plus, and I'm going to write a fraction. I'm gonna just pause right here, and I'm gonna say this is where the most confusion happens in this lesson. So if you're gonna pay attention to any part of this video, hopefully this is it. The fraction always. So we're in the second class to find the 10th number. How many numbers are in the second class? There are 8 numbers in the second class. You see that right there? There are 8 numbers in the second class. So that's my denominator. Of the 8 numbers available in the second class, how many of those 8 numbers do we need to get to the 10th number overall? That's where these red and blue numbers really come into, red and black numbers come into play. After one class, we have 3 numbers. 3 plus what gets me to 10? 7, Mr. Clody. 3 plus 7 gets you to 10. The 7, ladies and gentlemen, is the numerator. So let's think about what we just did right there. The second class has 8 numbers to pick from. To get to the 10th overall number, we need 7 of those 8 numbers. I hope that that was a clear way to explain that. 8 numbers are in the second class. We need 7 of those 8 numbers to get to the 10th overall number. Then don't forget, it's of the distance from point A to point B. So it's the width times the width. You always multiply by the class width at the end. And if you do that, you'll get 10.875. Do we round that off, Mr. Clody? No, because we want to be exact, because our verbal is exact. And because it's the first quartile, I'm going to say that 25% of the data is less than or equal to 10.875. Congratulations, we just found the first quartile. How about the second quartile? Oh, wait a second. Let me draw a dividing line here. The second quartile, isn't that just the median? It is. Didn't we already find the median? We did. It's right there, 14.5. I'm not doing it again. I don't care what you say. All right, good. That one's done. Yay. All right, let's get to Q3 then. Q3 is 3/4 of the way through the data. 3/4 of 40 numbers is the 30th number. But where will the 30th number put us on this table? This is where these are where the blue numbers really come into play. After 3 classes, we've got 26 numbers. After 4 classes, we've got 34 numbers. So the 30th number must be hiding somewhere within this class right here, right? Between 26 and 34. So the 30th number is hiding in the 4th class. Keep in mind, before we go any further, what's the lower limit of that? It's 16.5. Keep in mind also, there's 8 numbers in the 4th class. Keep that in mind as well. Okay? So, with that being said, I'm going to make a note of this right here. The 30th number is hiding somewhere within the 4th class. And so to find Q3, I'm going to start with the lower boundary of the 4th class, which is 16.5, and I'm going to add fraction. There were 8 numbers in the 4th class. That is my denominator. That's huge. Now, how many numbers were there leading up to the 4th class? How many numbers were there total after 3 classes? 26 total numbers. Here's what you have to do in your brain. 26 plus what gets you to 30? Plus 4, Mr. Clody. 26 plus 4 gets you to the 30th overall number. That, ladies and gentlemen, is my numerator times the class width of 5. So everybody, that is what is going on right there. Of the 8 available numbers in the 4th class, I only need 4 of them to get to the 30th overall number. I hope this is starting to make a little bit more sense right now. And what I get is actually a nice pretty number, 19. And what could I say for my verbal? I could say that 75% of the data is less than or equal to 19. Congratulations, we just found all the quartiles. All right. I would say questions, but I know you can't ask them. This is a video. All right. So we're now going to get to the deciles. Okay, and that's 10 equal areas. Now we're going to start to fly a little bit more quickly. Okay, and it's still D1 through D9. So let's find D2. Let's find the second decile of this data. So in terms of a fraction, the second decile is what, 2/10 of the way through the data? Well, what's 2/10 times 40? 2/10 times 40 is the 8th number. Which class does the 8th number put us in? Well, there's 3 numbers after one class, and there's 11 numbers after 2 classes. So the 8th number, I think you will all agree, falls somewhere within this second class. So I'm going to scroll down now. Why am I stuck? Now let's select. Let's go. Yeah, I guess whenever I'm in doubt, I can just press select. And then I know that I'm going to be somewhere within the second class. I know one of you in class told me that. Just press select. Okay, so to find the second decile, I'm going to take the lower boundary of the second class, which is 6.5. Keep in mind as well, there's 8 numbers in the second class, and there's 3 numbers in the first class. I'm not going to scroll down. So I'm going to take the 6.5 plus, there's 8 total numbers in the second class. 3 plus what gets you to the 8th overall number? 3 plus 5, Mr. Cody. That's right. So of the 8 numbers available in the second class, I only need 5 of those numbers to get to the 8th overall number. Okay, times the class width. And I get my second decile of 9.625. And then a quick verbal. D2, that's what, 20%? So 20% of the data is less than or equal to 9.625. The benefit of watching, of creating a video is that you could replay this, pause it, do whatever you need to do, watch it as many times until it begins to make sense. I hope I'm explaining it accurately. All right, one more, and then I'm actually done here. Last example, this is it. Last example. It's the percentiles. And it's 100 equal areas. It's still P1 through P99. Let's finish class by finding the 67th percentile. So as a fraction, I'm not even going to reduce that. Well, I can't. It's 67 100ths of the way through 40 numbers. And if you do 67 over 100 times 40, you get 26.8. So it's the 26.8 number? Question is, Mr. Colodi, should I take 26.8 and round it up to 27? And the answer is, are we using the word approximately in our verbals? The answer is no to approximately, and no, we don't round it. So let's scroll all the way up to the top here. Where would the 26.8 number put us? Wait a second. After 3 classes, there's 26 numbers. 26.8 is just beyond 26. So wait a second. So that means the 67th percentile is just barely in the 4th class. Like there's 26 numbers after 3 classes, so we need to just barely go into the 4th class. How many numbers are in the 4th class again? 8. What's the class boundary of the 4th class? 16.5. I got my finger just close enough that it did that, sorry. So 16.5. So this is just barely putting us in the 4th class. So to find the 67th percentile, I am going to start with the lower boundary of the 4th class plus of the 8 numbers available in the 4th class. Now listen, after 3 classes, there's 26 numbers. 26 plus what gets you to 26.8? 0.8, Mr. Colodi. That's right. 26 plus 0.8 gets me to 26.8. You could have a decimal, Mr. Colodi, in your numerator. Yes, you can. Last but not least, times the class width. And that equals, after all that hugabaloo, a nice pretty number. And I could say that 67% of the data is less than or equal to 17. Okay, so ladies and gentlemen, I hope you found that helpful. Again, if it seems confusing, watch it again. Watch it again until it's not confusing. All right, everyone. I will see you later. I just got to find my mouse and stop recording.